realized I didn't finish all the labeling, so I'll finish that right now. Right here is the work that we did for the mean absolute deviation. To get the mean absolute deviation of the sample, we added the 3 absolute deviations and divided the total by 3, since there was 3 numbers in here. Remember that when you calculate the mean absolute deviation of a sample, there's no adjustment. The adjustment is only done when you're averaging the squared deviations to get the sample variance and then the sample standard deviation. So I'll label this as the mean absolute deviation. I'll abbreviate like this. So for the entire population, the mean absolute deviation is just the mean of the absolute deviations. In this case, it's the total of the absolute deviations divided by 5. For the sample, the mean absolute deviation is just the mean of the 3 absolute deviations. So all you do is add the 3 absolute deviations and divide the total by 3, and that gives you the mean absolute deviation of the sample. To get the variance of the population, you find the mean of the squared deviations. In my example, we added the 5 squared deviations and divided the total by 5, and then that gave us the mean of the squared deviations, which was our variance. And then once we found the square root of the variance, we found our standard deviation. When we were finding the variance of the sample, what we did was we found the mean of the squared deviations, but we actually adjusted the formula, meaning we added the 3 numbers and divided by 2 instead of 3. So it isn't really the mean, it's an adjusted mean. And our sample variance came out to this number right here after dividing by 2. And then the square root of the variance was the standard deviation. So if we had 4 people in our sample, then we would add the 4 numbers and divide the total by 3, because 3 is 1 less than 4. If we had 5, let's say that this was a population of 10 people, and our sample was 5 out of the 10 people. So our sample has 5 people. In that case, we would add the 5 squared deviations and divide the total by 4, since 4 is 1 less than 5. So you don't always divide by 2. The reason you just always divide by 1 less than the number of squared deviations. And since we had 3 people, 1 less than 3 was 2. And I'll also do some labeling that I haven't done yet. Over here, I wrote out the variance under here, so I'll do that over here too. The variance of the sample was 20.5. Let's also write the standard deviations under here too. The standard deviation of the population was 9.61, and the standard deviation of the sample was 4.53. And actually, the variance and standard deviation are the only formula that's adjusted when you have data from a sample. None of the other formulas are adjusted when you have data from a sample. The range is calculated the same way, regardless of whether it's a population or a sample. The mean, median, and mode are calculated the same way, and the mean absolute deviation is calculated the same way. The variance and standard deviation are the only 2 values that are calculated differently when the data comes from a sample. So if I wanted to calculate the mean of a population, I add all of the data values in the population, and I divide by the number of population members. If I want to calculate the mean of the sample, I add all of the data values in the sample and then divide the total by the number of sample members. So the mean is the same formula regardless of whether it's a population or a sample. Just like how I said of how the range, median and mode, and mean absolute deviation also don't change when the data comes from a sample. It's only the variance and standard deviation that has a different formula when the data comes from a sample.